Hello students, let's discuss chemistry paper of 2025 Goa board. What I'll do over here is I'll solve the part where the explanation is needed. Otherwise the theoretical part you can obviously Google and get the answer. So here the first thing is the hormone that contains the iodine is hormone that contains iodine is thyroxine. Okay. Theoretical question. What happens to the value of the delta G when a catalyst is added to it? See, delta G is a Gibbs free energy. When catalyst is added, we know that plot. What does a catalyst do? Okay, the plot is this way. One curve is this way. This is for the catalyst. This is without catalyst. I will say this is the curve for the without catalyst, and another curve with catalyst is this. Like this is the curve without catalyst, with catalyst I mean. So what it does is just it decreases the activation energy, right, with catalyst. So catalyst does not change a Gibbs free energy delta G. So the answer over here is that it does not change a Gibbs free energy. Okay, delta G of the reaction, it remains unchanged. Next question, the compound given over here, and they have asked what kind of compound it is: primary alkyl halide, primary allyl halide, secondary or a secondary benzyl halide. We draw the structure, open chain structure of this. This is CH3, this is CH2. On this carbon there are two methyl group. You see that there are two over here, it is written in the bracket. So this is the thing, this is CH2, and then there is Cl. If you see, this halide is connected to a carbon which is further connected to only one carbon. So this is a primary alkyl halide, right? So the answer is this one, primary alkyl halide. Next is, which of the following statement is true regarding the conductivity of the electrolytic solution? So conductivity of the electrolytic solutions depends on the ions and its mobility, right? More is the mobility of the ions, means movement of the ions, right? Bigger ions are less mobile, the mobility is less for the bigger ions, and the smaller ions are more faster to move. So smaller ions show more conductivity compared to the bigger ion. So what is the statement? First statement, it is independent of the size of the ion. No, it is dependent on the size of the ion. So this statement is wrong. It is independent of the viscosity of the solution. It is independent of the viscosity of the solution. No, again viscosity will decide the mobility of the ion, how free the liquid is. If the solvent which is there it is more viscous, the mobility of the ions is restricted, right, and it is dependent on the viscosity. So this statement they are saying that independent, this is also wrong. It decreases with temperature. No, what happens is with temperature the mobility of the ions increases. This is also wrong. Then it depends on the solvation of the ions present in a solution. See, what is the meaning of solvation is that let's say there is one ion, let's take an example of the NaCl. You put this into water, what you get is Na plus, I will write aqueous over here, and a Cl minus aqueous. What does this mean? Na plus aqueous means aqueous represents a water molecule, water. So over here this is Na plus, this is Na plus, and water molecules, this is Na plus, and the water molecules, the negative part of the, that is oxygen, is negative part of the water molecule, partially negative due to polarity, due to electronegativity. Like this the water molecules will be surrounded by that Na plus. Now on what factor this will depend? This is called as solvation or the hydration. More is the charge density, like more is the charge density, more will be water molecules surrounded around this Na plus. And what about Cl plus? Also Cl minus, I mean there will be water molecules, but I can show the representations this way. the hydrogen, the positive part will be pointing towards the, this is what the hydration is, this is what the hydration is, means more is the charge density, more will be what, solvation, and if more water molecules are surrounded, then what will happen, the mobility is again restricted. So over here what happens is that charge density decides the mobility of the ion. So it depends on the solvation. Yes, if solvation is more, certain many times it happens that ion is smaller, like Na plus ion is smaller, but its charge density is more compared to the other ions of the group. So what happens is that it is more solvated, its mobility is less, right? So it will depend upon the solvation of the ion. So this answer is the correct one. Okay, next is the correct order of the boiling point of alcohols having same number of the carbon atoms. Let's consider alcohol which is having same number of the carbon atom. Let's consider this alcohol, CH3, like this is butanol, a primary alcohol I am considering over here. This is primary alcohol. Secondary alcohol containing same number of the carbons. I can write secondary alcohol as this. This is secondary alcohol containing same number of the carbon atoms. And a tertiary alcohol will be this. Okay, this is tertiary alcohol. So here alcohol, whenever we talk about the alcohol, what kind of intermolecular force which exists between the molecule? It is very simple. It is, if I consider, I'll just write the general formula of the alcohol, ROH, and let's say there is another alcohol molecule. What will be the force which is existing between these molecules, which holds the molecules together? It is the hydrogen bonding force. This is the hydrogen bonding force. This is hydrogen bond force, right? Hydrogen bond force. Now, what is the criteria to have a hydrogen bond force? It is, there should be a electronegative element and a hydrogen, provided hydrogen is connected to what? Electronegative element, right? Then only you can see that hydrogen bond. But what happens in case of alcohol is that there is a hydrogen bond, but with increase in branching, the tendency to form the hydrogen bond is decreasing. It decreases. So over here, the primary alcohol will have like boiling point. Now, if that force is stronger, what is the meaning of boiling? What is the meaning of boiling? Let's say there is a alcohol and this is the ROH and another ROH molecule is there. Okay, there are many lot of ROH molecule. ROH means let's consider a methyl alcohol. Many methanol molecules will be there, and there will be a force of attraction between this hydrogen and this oxygen which is holding these molecules will be there, right? So when you supply the temperature, this force is reduced and some molecule escapes out from the bulk, right? If this force is very, very strong, then what is going to happen? The molecules will escape the bulk at...
A subject like physics can be a tough nut to crack in the last 40 days. But you need not worry if the subject experts are there with you. We are here at Prabhu Classes to guide you with a rank booster course for NEET 2024. So if you want to get a solid edge in your preparation, come and join us. Contact on the numbers you need.
Certain higher temperature, right? So what will happen? It will depend upon the strength of the intermolecular force, that is hydrogen bond over here. So here what is going to happen is As the branching increases, what happens is the intermolecular force, that is hydrogen bond force, decreases. So branching is very less for the primary alcohol, so the intermolecular force for the primary alcohol will be maximum, and the order will be primary, secondary, and then tertiary. Okay, the metallic radii of the transition element are given below. The metallic radii are given and you are told to ask, you are asked the highest density. So density is equal to mass upon volume, right? So if you go by that trend, if you see that over here, this is having the highest atomic radius, but highest atomic radius means volume will be more of that copper, right? So you will say that density of the copper will be least. No, but over here, like this is studied as one of the exception over here. The thing over here is that the mass of the molar mass of the carbon atom is more pronounced, or not exactly a molar mass of one carbon atom is comparatively much higher than the nickel or a cobalt. So here this mass is more pronounced than the volume increase, right? So the density of the copper will be higher. The product form in an aldol condensation. Now what is aldol condensation? Like we'll do the mechanism. Let's take a aldehyde, one aldehyde I'll take, one example I'll take. Right, first is a generation of the nucleophile using a base. Step 1 I'll write. Step 1. See, certain reactions in organic, you should know the mechanism, or at least what is forming as a nucleophile over there, or something. This you should be knowing, right? So here there is a OH minus, and this is your hydrogen. It will abstract this. So step 1 is generation of the nucleophile. You get the nucleophile as this. You remove the alpha hydrogen. This is alpha hydrogen because it is connected to a functional group. You are removing that, and this negative charge form is comparatively more stable because it is in the conjugation with this pi bond, right? So this is the nucleophile. Step 2 is attack of the nucleophile on a fresh molecule, right? This is what we do in a aldol condensation molecule, CH2 minus. I'll write this hydrogen downside this way. Aldehyde's hydrogen down, and this will attack over here. This pi bond will break the further. This will change to O minus, and I can write that OH over here. This hydrogen is down, then this is our CH2. So what you are getting over here is this is my alpha carbon, right? This is my alpha carbon because the functional group aldehyde is connected, which is principal functional group, and this is my beta, right? So aldol condensation, like I have started the reaction with the aldehyde, right? So I am getting beta. On beta position there is a hydroxy, beta hydroxy. In this case, it is aldehyde. If I started the aldol condensation with a ketone, if I take this kind of ketone, then I would have got the answer as beta hydroxy ketone. So this is this is called as aldol. Why this is called as aldol? Because there is a aldehyde and the alcohol, right? So answer is beta hydroxy aldehyde or a ketone. There is no carboxylic acid and all these things are not formed. So it is beta hydroxy aldehyde or a ketone. So this is your answer for this. Okay, here very important thing is they have given a Henry's constant. See, Henry's constant is the characteristics of a particular, it varies from a gas to gas, right? And Henry's constant, the question, we'll read the question first. The KH values for the different gases are given: argon, carbon dioxide, formaldehyde, methane, and yeah, the correct order of the solubility. The solubility is inversely proportional to Henry's constant. Henry's constant, like higher is the Henry's constant value, solubility will be less. So over here, which is having the Okay, since it is increasing order, which is having highest value of KH. I think argon is having the highest KH value, that is 40.39. So it will have least solubility. Then carbon dioxide, right? Then carbon dioxide. Then formaldehyde is how much? Yeah, carbon dioxide is 40, then 1.67. Then 1.83 into 10 raised to minus 5. Right, that is for formaldehyde they have given. That is least, like that is least, formaldehyde is least. So formaldehyde will have maximum, and in between what is there? Methane. So option, this should be the correct one, right? Write the chemical name of the vitamin C. Vitamin C is ascorbic acid. Draw the structure of the chromate ion. Now question number 10, what is the meaning of the chromate ion? Chromate ion is, I'll draw this, it is CrO4 2 minus. Structure will be this, C double bond, Cr double bond O minus and the O minus. This is what the structure for the chromate ion. Write the structural formula of 2-ethoxy 2-methyl propane. 2-ethoxy 2-methyl propane means parent chain is propane. Okay. On second there is ethoxy. Like this is ethoxy. On second carbon there is methyl also. So this is what the structure or expected. Define activation energy. Just a definition. You can, if you have written this definition, then you will get the marks. Okay. Identify the structure of the missing component in the given reaction. So toluene, like this is the toluene, and concentrated HNO3 and a concentrated H2SO4. This reaction is nitration, right? And what kind of group is this? This is ortho para directing to incoming electrophile. What is the electrophile over here? By combination of this, you get a NO2 is a electrophile. So major product, major is always a para product is always major over here. So we'll write the major product. We'll write the major product over here. CH3 and NO2 will come over here. Now next is what? It is written Fe and HCl. This tells about the reduction. This is the reducing agent. Now if you do the reduction of the NO2, what is reduction? Removal of oxygen. This is the definition of the reduction, or addition of the hydrogen. This is also the definition of the reduction. So what is done over here is removal of the oxygen as well as addition of the hydrogen is done. So this is methyl and this is changes to NH2. NO2 changes to NO2. And that is what the product is. This 4-amino toluene. This is 1, this is 2, this is 4. Right? Toluene is the parent over here. So it is 4-amino toluene. Right? This is what the answer is. Okay, this is theory. You can of course know the diagram and the reactions. State Faraday's law also. This law you can write from the book, but what about the answers for this? Calcium chloride. So you are asked limiting molar conductance of the calcium chloride. right? 1 minute down. So lambda naught m of calcium chloride, like according to the Kohlrausch law or independent migration of the ions, like calcium will basically split as what? Calcium chloride in the aqueous medium, this will split as calcium 2 plus aqueous plus 2 times Cl minus ions aqueous. Now you very well know what is the meaning of aqueous, right? So this will be lambda naught m of calcium 2 plus, okay, it is written Ca capital, it is Ca2 plus, okay, or we will write it is this way, Cl2 plus 2 times lambda naught m of Cl minus. Answer is very straight. Calcium 2 plus independent ion, they have given 119.0 plus 2 into 76.3. So the answer which is going to come over here is 271.6 Siemens centimeter square per mole. This unit is very important. Without this unit you are not getting the marks, half marks you are losing over here. Write the IUPAC name of the following complexes. So I will do with this first one. See, first, whatever comes first, we write it first, right? That is, potassium is first over here. So I am writing potassium. Will not write that as a tri. Since there are 3 potassium, we don't write that as a tri, or whatever number of the potassiums are there, we just write a potassium, right? This is the counter ion. Then there comes a coordination sphere. In a coordination sphere, we always name a ligand first, right? Ligand is what? Our oxalate, C2O4, 2 minus. This is the oxalate, this is the ligand which is there. So in this, it is trioxalate. 3 oxalate ligands are there. So I am naming that first. Trioxalate 2. Since the ligand is negative, we replace that E with O. Oxalates E with O, that is trioxalato. Then aluminum is in the negative coordination sphere. Like if you see over here, this is the negative coordination sphere. So we write aluminate, right? In bracket we'll write the oxidation state of the aluminum. Like 1 potassium will form the equation for this to find the oxidation state of the aluminum, right? 1 potassium is having a plus 1 of charge, so 3 into plus 1. Aluminum I'll put as X, and 1 oxalate is having a minus 2 of charge, 3 into minus 2, which is equal to 0. Whole compound is neutral, complex is a neutral over here. So this is 3 plus X minus 6 is equal to 0. X is equal to what? 6 minus 3. X is equal to plus 3, right? So over here the thing is going to come this way. What about this next structure? Okay, what about this next structure? This compound, what is the IUPAC name of that? What happened? Sorry. Okay, I'll clean this. Over here, it is starting with the coordination spheres first. So whatever is there inside the coordination sphere, that is ligands. We name the ligands first. So there are 2 ligands. One is water. Water name for the ligand is aqua and amine, right? So you need to write either amine or aqua. Which comes first in alphabetical order? AM. Q comes later, no? Right? So you are writing amine first. So the name for this compound is tetraamine double M. Okay, this is very important. In this case, you represent that to be double M. If you are doing the IUPAC nomenclature of the organic compound, amine is a functional group over there. You put a single M. Know this difference. So this is tetraamine diaqua. This chromium is in what coordination sphere? This is in a positive coordination sphere. So this is, you are writing just as it is, chromium. Its oxidation state will be what? We'll write this as X, chromium. Amine is a neutral ligand. Even water is a neutral ligand. Plus 3 into chlorine is -1 equals to 0. So X minus this becomes 0. So X minus 3 is equal to 0. Therefore X is equal to plus 3. So over here you are putting oxidation state of plus 3, and then counter ion is a chloride. Again you are not putting di, tri or something like that, right? So this is the answers. Here, on the basis of valence bond theory, deduce the hybridization geometry of the high spin complex. You need to understand that when there are 6 ions connected, like 6 ligands are there, the possibility of the hybridization is either sp3 d2 or other possibility is d2 sp3. Like this is known as outer orbital complex and this is known as a inner orbital complex. Geometry will be always octahedral when the 6 ligands are connected. Okay, this is something which you should know. Since you are told to do on the basis of valence bond theory, you should be doing, showing that, presenting nicely in the paper that what is valence bond theory, and you know that, right? Valence bond theory, they have written cobalt over here. Like cobalt electronic configuration. What is the electronic configuration of the cobalt? Outermost electronic configuration. Cobalt is 27. Atomic number for the cobalt is 27, right? So cobalt electronic configuration is 4s2 3d 7. I will write cobalt 3d orbital comes first, third shell comes first. Right, there are 7 electrons over here. 1, 2, 3, 4, 5, 6, 7. Then there is 4s orbital. There are 2 electrons over here. Then there will be a 4d. Sorry, I mean 4p will be there. 4th shell. P orbital will be there, which is empty in this case. Cobalt is in what oxidation state over here? Like cobalt is in what oxidation state? That we have to understand. Let's find the oxidation state of the cobalt in COF6. I will put that cobalt as X plus 6 into 1 fluorine is -1 equals to -3 because the charge on that coordination sphere is -3. So X minus 6 is equal to -3, X is equal to -3 plus 6, X is equal to plus 3. So cobalt is in plus 3 oxidation state. So if you have to remove the 3 electrons, which one you will remove first? The electrons which are outermost. So 2 from here and 1 from here. So here there will be just 6 electrons, 1, 2, 3, 4, 5 and 6. Now cobalt, the fluorine which is there, fluorine is a weak field ligand. So whenever there is a weak field ligand, what happens? Weak field ligands. Pairing does not take place. Right? These electrons will not pair. So I will write cobalt in CO F6 3 minus. So I will write the electrons of the cobalt ion as it is 1, 2, 3, 4, 5, 6. So ligand is what? Both the electrons are from the ligand. In coordination sphere, the bond which is formed, both the electrons are from the ligands. So I will require this. I will clean this part over here. Then there is 4d. Again d I have to include because it is outer orbital complex, which was empty till now. Now it's going to get filled. right? These are the electrons of fluorine. This is from fluorine. How many fluorine? Total 6 fluorine. 1 2 3 4 5 and 6. So what is the hybridization over here? What is this hybridization? One orbital of s, 3 orbitals of p and 2 orbitals of d. So the hybridization over here is sp3d2, right? So hybridization is sp3d2, and when this hybridization is there, what is the geometry? Geometry is octahedral. This is octahedral. If you have written the answer as octahedral and if you have shown this, then you will get these 2 marks. Okay, you have to show this. So you have to mention, like over here also, what is this? This is of the fluorine. These electrons are of the fluorine minus. These electrons are of fluorine minus. Fluorine minus. Here it is carbonyl. 4 ligands are there. So whenever there are 4 ligands, structures are also different, hybridizations are different. So you can have either sp3 as a hybridization or dsp2 as a hybridization. If your hybridization is sp3, then it is tetrahedral. And your sp3 then tetrahedral, then dsp2, then square planar. Square planar. Right? Let's find what is the hybridization over here. Nickel's electronic configuration is atomic number 28, right? So it is 4s2 3d8. There is 0 charge on the coordination sphere, and carbonyl is also neutral. So what will be the oxidation state? It is x plus 4 into 0 equals to 0. X plus 0 is equal to 0. X is equal to 0 means there is no charge, or there is oxidation state of the nickel in this case is 0. That is what we can consider, right? So I am writing the electronic configuration of the nickel. So that is 3d. So there are 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 8. Then there is 4s, there are 2 electrons over here, then 4p, this is empty, right? Nickel is in same oxidation state, same, 0 charge is there over here. So oxidation state is not changing. So I am writing nickel in nickel carbonyl. So over here, since carbonyl is a strong filled ligand, what will happen? All the electrons will pair up, means there are 8 electrons. I will write it this way: 1 2 3 4 5 6 7 8, and even these electrons I am writing over here. Now what are the empty orbitals? Because they are in a over here, these are the electrons of the carbonyl I am writing. These are the electrons of carbonyl over here I am writing. So total 4 ligands. So here this is of the carbonyl. This electron pair is from the carbonyl, right? CO it is, not cobalt. So hybridization is what? One orbital of s, right? This is 4s and this is 4p, and 3 orbitals of p. So hybridization is sp3. If your hybridization is sp3, okay, they did not ask a structure, they ask a magnetic character. Since all the electrons are paired, hybridization is sp3. Since all the electrons are paired, magnetic behavior is diamagnetic, right? Okay, select the correct compound from the following given pair. Which halogen compound from the following will undergo SN2 reaction? See, SN1 reaction is the reaction which goes via formation of the carbocation, and SN2 there is no formation of the carbocation. So SN1 is favorable. SN1 is favorable for tertiary carbocation, or tertiary carbocation is formed that is more stable, or SN1 is favorable for tertiary alkyl halide, which in turn gives a tertiary carbocation. SN2 is favorable for a primary alkyl halide. So in this case, if you see this structure over here, this is cyclohexane and this is CH2, and then there is a chlorine, a bond line structure they have given. Over here, this is what? This is a carbon. This is a carbon. And here there is a Cl. So this is a chlorine which is connected to a carbon which is further connected to only one carbon, right? So this is a primary alkyl halide, right? What about this? I'll write this as a carbon, and this is the chlorine. This is the chlorine which is connected to this carbon which is further connected. Like I'll write open chain structure. Cyclohexane means this, CH2, CH2, CH and Cl, right? This is what the cyclohexane, chlorocyclohexane. Here this chlorine is connected to this carbon, it is further connected to two carbons. So this is secondary alkyl halide, right? Secondary alkyl halide. So SN2 is favorable, like reactivity of the SN2 is of this order. It is primary is more favorable, then secondary and tertiary is least favorable for the SN2. So over here this is primary alkyl halide, so this has more probability chances to go via SN2 mechanism, right? Which molecule from the given pair is chiral? Chiral means there should be a presence of at least one carbon which has all four groups, different group attached to it, right? So if I write the first structure, this is open chain structure. We'll write the open chain structure for this first structure. I am writing hydrogen, Br. All four groups attached on that carbon should be different. Now if you talk about this carbon, this is achiral because three hydrogens same groups are connected. Again this is achiral because two similar group hydrogens are there. This is also a achiral carbon because there are two hydrogens similar are there. Again this is achiral because two similar groups are there. Means all four groups should be different. Now over here if I write, this is Br, this is hydrogen, this is that CH3 I am writing, CH3, right? I'll write it this way. CH3 I am writing open chain. This is hydrogen, this is hydrogen, hydrogen, hydrogen and a hydrogen, right? So if you see the first carbon over here, this is what? Same group, non-chiral. If you see this carbon, this is Br, this is hydrogen, this is methyl group and this is ethyl group. So that's why this carbon is a chiral carbon. So among this, the chiral carbon is this structure. The answer for this is this one. This is theory part, you can of course understand it. The element of the 3D series that exhibits maximum number of oxidation state, answer is manganese, right? Alloy which contains 95% lanthanide, answer for this is mesh metal. Okay, theory based question. Okay, first reaction over here, 21 organic reaction. They have given this compound. This is the structure C6H5CH and a CH2. What you are doing over here is a hydroboration oxidation. Hydroboration oxidation. Actually, this reaction is a hydration reaction, right? This reaction is a hydration reaction. Hydration of alkene. right? That is addition of water. This is addition of water to alkene. Now difference between an acid catalyzed hydration and a hydroboration oxidation is that acid catalyzed hydration can give you a secondary or tertiary alcohol, whereas hydroboration oxidation will always give you a primary alcohol over here. Means over here the product of the alcohol, product of this reaction will be C, double bond will go, it is an addition reaction. The OH minus, like water has two part, one is H plus and other is OH minus, right? So negative part will go to the carbon which has more number of the hydrogen. This is the way we can remember this, CH2 OH and the hydrogen, already there is one hydrogen and one hydrogen will come from the water. So this is what the compound you are going to get. Next reaction over here is you are adding an acid to the alcohol. I'll just add to this. You are adding acid to the alcohol. Now, adding an acid to the alcohol, what happens? Dehydration takes place. CH2, this is the thing. CH2OH over here. This is H. Dehydration means you are going to remove this set. Like sometimes there are two possibilities of the removal of the water molecule. That time you decide based on which will give you a more stable alkene. So here there is only one possibility of the alkene. You add a H2SO4. H2SO4, sometimes it is also given as just H plus. Dehydration, removal of this. So the product, what you are going to get over here is a propene. Right? This is what the answer is. The answer for this is propene. I will write over here. CH2. CH2 and for this the answer is phenol is treated with bromine water. Reaction 1, phenol is treated, this is phenol, this is orthopara directing, and bromine water you are taking, then all the orthopara positions will be occupied. So this is bromine, here there is, OH, Br and Br. This is number 1, 2, 3, 4, 5 and 6. Right, this is 5. Right. So 2, 4, 6. Name is 2, 4, 6. Tri-bromo phenol. Vapors of ethyl alcohol are passed over heated copper tubes. Ethyl alcohol, there is only one possibility of the OH on the first position. Whenever alcohol, like this is copper at 573 Kelvin. This is a reaction where we do the oxidation. So this primary alcohol will change to aldehyde, that is ethanol. Right, now oxidation, removal of the hydrogen. There is a removal of one hydrogen from here. That's why this is ethanol is the product over here. The questions are very simple this time. The paper was very easy. Okay, over here question number 24. Hoffman-bromamide reaction. This first reaction is itself a Hoffman-bromamide degradation reaction. If you see the reagent, it is this. This reaction is so simple. This is amide reaction. You have to just remove this part, amide, like carbonyl part, and the product P will be this CH3, CH2, NH2. Like product Hoffman-bromamide reaction is known for the thing, like it gives the product one carbon less. So this is ethyl amine. This is Hinsberg reagent, benzene sulfur chloride. This is for the detection of the primary, secondary and the tertiary tertiary amine. So basically over here, if you want to write this reaction, we will write it this way. Mechanism, small mechanism, we can understand that this is sulfur double bond OCl minus, sorry, Cl, and this is our amine, that is C2H5 NH2. There is lone pair of electron. Obviously this sulfur is very much electron deficient, very strong electronegative elements are present on that sulfur, so this bond will break. This weakest bond is chlorine. Chlorine is a very good leaving group also, it is known as. And the compound what you are going to get over here is that S double bond O NH. One of the hydrogen will go with a Cl to form a HCl, NH C2H5 plus HCl. This was the product which was expected from you. This is our Q. Okay, for the reaction H2 plus Cl2 and 2HCl, the rate law is this, means over here it is 1, right? Nothing is there, means I can multiply it 1. What is the order of the reaction? Basically we write rate to be is equal to, rate law expression, rate is equal to K, concentration of reactant raised to, let's say N. N is the order of the reaction, or we'll write raised to X. When this will be 1, when X is 0. What is this? X represent order of the reaction, order of reaction. So rate will be is equal to K only when reactant order is 0. Anything raised to 0 is what? 1. So rate is equal to K. So over here order of the reaction is 0 order. Right? State the unit of the rate constant for the 0 order reaction. Unit of the rate constant for the 0 order reaction we can write as rate is equal to K reactant raised to 0, no, concentration of the reactant raised to 0. Units of rate is moles per liter per second. Okay, unit of rate constant is asked, right? Not rate. Units of rate will be always same, whether it is first order, second order, third order, it will be always same, that is moles per liter per second. The units of rate constant is going to vary. So concentration unit is moles per liter and this is 0, right? Therefore unit of K will be what? This is becoming 1, right? So here unit is moles per liter per second. This is the answer. Okay. Okay, here half-life period for the first order reaction is given to be 693 seconds. Calculate the rate constant. See, half-life for a first order reaction is given as 0.693 upon K, right? You need to find a K for this first one. K is equal to 0.693 upon T half. So 0.693 upon T half is given to be 693. So same number could be written as 0.693, or I can write this as 693 into 10 raised to minus 3 upon 693. This and this will get cancelled. So K will be is equal to 10 raised to minus 3. Unit will be, for this was second, right? Right, time was in second. So this is unit is per second, 10 raised to minus 3. Next, time required for the 90% completion of the reaction. So T is equal to 2.303 upon K log of R0. R0 is the initial concentration and R is the concentration of reactant at time T is equal to 0. So over here this is 2.303. K is what? 10 raised to minus 3. And let's say initial concentration I am considering maximum R0, that is 100. and 90% completion. If 90% reaction is complete, then how much percent is left? Just 10% is left, right? So this will be the thing. So this is 2.303 into upon 10 raised to minus 3 into log of 10. Log of 10 is 1, right? Upon 10 raised to minus 3 is log of 10 is 1. So this is 2.303 into 10 raised to 3 seconds. Time required for 90% completion is this. Anyone who is getting 2.303 in 10 raised to 3 seconds, they are correct. Identify the name of the reaction and which are illustrated by the following chemical equations. So first reaction, if I write, it is this C6H5Br plus 2 moles of Na and CH3Br. This is aryl halide. If you see, this is aryl halide, and this is alkyl halide. What do you get? You will get that is toluene plus 2 moles of NaBr, or other name is methyl benzene. Also you can write methyl benzene. And this name of this reaction, they have asked the name of the reaction. This is Wood's fatigue reaction, right? Second is, this is a part of a Sandmeyer's reaction. This is primary aromatic amine, a diazonium salt. Name of the reaction for this is Sandmeyer. I will write the name of the reaction first. This is, second one is Sandmeyer's reaction. That is benzene, diazonium salt is there, that reacts with HCl. The name is only asked over here. This is Cu2, Cl2, you get chlorobenzene. Like, this question is more about writing the name of the reaction. Reactions are already given. Okay, this is a halogen exchange reaction. There are two reactions we learn in a halogen exchange, that is Fittig and a Schwarz reaction. Sorry, Filkenstein and a Schwarz reaction. So over here, this is preparation. This is specific reaction for the preparation of the fluorine, and this reaction name is known as Schwarz reaction. Schwarz reaction. Okay, it is halogen exchange reaction. I will not write that again. It is halogen exchange reaction. Schwarz reaction. Draw and label the phase and the meridional isomer of this. Write 1 point of difference between homoleptic and heteroleptic complexes. Okay, we'll do with the first one. Like, there are total 6 ligand, 3 plus 3, 6 ligand. It forms the octahedral ligand. Phase means facial. Like, I will draw the structure. This is cobalt. This is the ligands. This is the positioning of the ligands. Like, I can show that this is lying in one plane. This is lying in one plane. I can do this, right? So over here, phase means NO2 is here, NO2 is here, and NO2 is here. Like, this is what the position. And another NH3 you can write over here. Why it is called facial? NH2, NH3, right? This is NH3 because it is forming a face, one face of the octahedron. You see this. It is forming the one face of the octahedron. In exam, we shouldn't be showing this, right, shaded part, only positioning of the NO2. Means two in a plane and one on the vertical axis. This is face, right? Face. And meridional will be like this is NO2. I am writing all the three NO2 in one plane, and this is NH3. They are in another plane, NH3. So you see this is one plane. This is what the structure you were expected, not the dotted line, right? So these are the things were expected. Write the points of differences between homolectic and heterolectic complexes.
A subject like physics can be a tough nut to crack in the last 40 days. But you need not worry if the subject experts are there with you. We are here at Prabhu Classes to guide you with a rank booster course for NEET 2024. So if you want to get a solid edge in your preparation, come and join us. Contact on the numbers you need.
Compound which is given, say actually this is a derivative of the aniline. If you consider the aniline structure is this, we call this to be aniline, right? If you put one methyl group, then we'll call that to be N-methyl aniline. There are two methyl group on this, right? There are two methyl group on this. There are two methyl group on this. So the name will be N comma N, because there are two methyl group, right? N comma N dimethyl aniline. Name the foul smelling compound obtained when aniline is subjected to carbylamine reaction. Basically carbylamine reaction produces isocyanide, right? If you see this is the reaction for that, and this is a foul smelling compound. This is isonitrile benzene. Okay, this is called as isonitrile benzene or benzene isonitrile. Okay, the linkage between a monosaccharide unit is called as glycosidic linkage. Sucrose is the non-reducing sugar, okay, which gives you D-glucose and a D minus fructose. And in this case, when glucose is reacted, you get the N-hexane, which tells this reaction is actually the proof that a carbon or a glucose has 6 carbons connected one after another. Okay. Okay, here is the question. An alkene having molecular formula C5H8, right? This is the formula of an alkene C5H10. Upon ozonolysis and further hydrolysis, basically this tells about the further hydrolysis, forms the compound B and C, and B gives Felling's test as well as positive iodoform test. Compound C gives a positive iodoform test and not Felling test. Write the appropriate chemical equation involved. Okay, so C5H10. Now it is alkene. We don't know what kind of alkene, where the double bond is there. But whenever you do the ozonolysis reaction, simple way to remember the ozonolysis reaction is this way. Let's say this is A, this is B, this is P, and this is Q. You break this, and you get these compounds, right? You get these compounds. Depending on this group, you name them, whether it's aldehyde, ketone, something this way. If we get to know that what are these compounds, I will easily able to tell you what will be that alkene is, right? So over here, a positive iodoform test, B and C, C as a product. Compound B gives a Felling's test as well as positive iodoform test. Now Felling's test is positive for aldehyde, right? And iodoform test condition for this test to be positive, there should be presence of at least one methyl group on carbonyl carbon, right? Now it is a aldehyde and it is also giving you positive iodoform test. So my compound, one of the compound, that is B is what? It should be this aldehyde, because this is the only aldehyde which will give you a positive Fehling test and a positive iodoform test, right? Now 2 carbons are done. There are total 5 carbons over there. And what is the next thing? Compound C gives only positive iodoform test. Now positive iodoform test, to get there are 3 carbons. How you will use that? It is this. Only this, if let's 3 carbon ketone, only this ketone can give you a positive iodoform test. Means you are getting the compound, you are getting the compounds this way. You are getting 2 compounds over here. One is this, and this is just a trick to understand a ozonolysis reaction followed by hydrolysis. So what is that alkene? Alkene will be CH3, CH, CH3 and CH3. Now if you do the numbering, you will do it from here. This is 1, this is 2, 3 and 4. 2 methyl but 2-ene, right? The question is, write the appropriate chemical equation involved in the formation, right? This is the chemical equation involved in the formation of the compound made from the alkene. Also write the name of the compound B and C. So the name of the compound B and C, so this is the B, this is B, that is ethanol, and this is propanol, right? And this is fitting into that formula C5, what was that? This is fitting into that formula. What is that formula? C5H10. Like there are 5 carbon and 10 hydrogens over here. This is C5H10. Right? Okay. Predict which of the following ions will be colored in the aqueous solution. See, for the compounds to be colored in the aqueous solution, what is very important is there should be a presence of at least one unpaired electron in those ions, right? So then only we will get the compounds colored. Now chromium 3 plus over here, the chromium 3 plus, let's talk about this. Chromium's electronic configuration is 4s2, sorry, chromium's electronic configuration is 4s1 3d5. So chromium 3 plus will be what? 4s0, you remove one electron from here, 3d3, 2 electrons from here, means d orbital has 3 unpaired electrons. That's why this will show color, chromium will show color. I'll write over here, Cr3 plus will show color. What about Zn2 plus? Zn's electronic configuration is 4s2 3d10, and they are saying at Zn2 plus. Zn2 plus means 4s0 3d10, and if you see the d orbital over here, 1 2 3 4 5, There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No unpaired electrons. Since there are no unpaired electrons, this compound is not going to show you a color. Now copper plus 1. Copper's electronic configuration is what? Copper's electronic configuration is 4s1, 3d10, and if you do it copper plus 1, it is 4s0, 3d10, right? So what is this? D is again having all the electrons paired 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So this is also not showing a color. Nickel 2 plus, nickel 2 plus. Nickel is what? 28, right? 4s2, 3d8. Nickel 2 plus will be what? 4s0, 3d8, right? And D8 configuration, there is unpaired electrons. That is 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons. That's why nickel 2 plus shows color. Right. So this will show a color. This will show color. So chromium 3 plus and a nickel 2 plus is the answer for this, which shows color. Okay, this is theory, you can refer to NCERT. Predict which of the following ions will exhibit a magnetic moment. Again, this question is similar to the color. Over here also, for the ions to show a magnetic moment, there should be a presence of unpaired electron. Like scandium 3 plus. Scandium's electronic configuration is 4s1, 4s2, 3d1. 4s2, 3d1. Scandium 3 plus will be what? 4s0, 3d0. There are no electrons only over here in the d orbital, no question of unpaired electrons. So here scandium 3 plus, the n value will be what? 0. 0 unpaired electron. What about iron? Fe is 26. 4s2, 3d6 is the electronic configuration, right? So Fe2 plus will be what? Fe2 plus will be 4s0, 3d6. d6 means it is having 1, 2, 3, 4, 5, 6. There are 4 unpaired electrons, so this will show a magnetic moment. What about titanium? Titanium's electronic configuration is 4s2, 3d2, and titanium plus 4 will be 4s0, 3d0. So 0 electrons, so this will not show. What about cobalt? Cobalt's electronic configuration is 4s2, 3d7, and cobalt 2 plus is 4s0, 3d7. Again d7 configuration, there are unpaired electrons in this. There is 1, 2, 3, 4, 5, 6, 7. 3 unpaired electrons. So cobalt is going to show you the magnetic moment. That's it. Okay, again these reactions and all, you can just refer to NCERT. Draw a neat label diagraph to represent the dependence of vapor pressure on mole fraction of the component in a binary solution. A graph is this way. Everyone knows that. Here let's say this is a mole fraction of the A and this is mole fraction of the B. A maximum value of the mole fraction can be what? 1, right? I can write this is equal to 1 and this is 0. And this is over here at this point, this is 0 and this is 1. Means over here only mole fraction. Here this is about the mole fraction. Vapor pressure is directly proportional to the mole fractions, right? I'll just write in this direction it increases. One increases, other decreases, other component, right? So here this is the vapor pressure. Maximum vapor. Here vapor pressure will be maximum only due to B. So I will write P naught B. Okay. This is the graph. And in this direction, here vapor pressure will be only due to A because B component is 0. So I will write this maximum vapor pressure due to B, P naught B, right? And this is about the P total, that is partial vapor pressure of PA plus PB. This is about the partial PB, and this is PA, right? And this is the representations, like you can show these gradings over here. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then it is 1. It is very irregular over here, but this is how you can show. Only this diagram was expected from you. Calculate the osmotic pressure of 5% weight by volume solution of a equimolar, molar mass is given. Okay, 5% weight by volume. 5% weight by volume. What is the meaning of this? 5%, 5 gram of solute is present in 100 gram, since weight by volume, since 100 ml of solution. Total solution is 100 ml. That is what it means. 5% means. You need to find the osmotic pressure. Pi is equal to CRT, right? And we'll consider I factor to be 1 over here. Okay, it is not given, so we'll consider urea. Okay, it is given urea, no? So urea NH2, CO NH2. This is not going to dissociate. For this, I will be always is equal to 1. For this, I will be is equal to 1. So where this will be 1. C is what? C represents the molarity. C represents the molarity, right? So we'll find the molarity. We have the weight and the volume of the solution. So molarity will be what? This is molarity. First we'll find the molarity of the solution. Molarity of solution, that is C. Number of moles of solute is 5 by 60. 60 is the molar mass given over here, right? 5 by 60 divided by volume of solution liter, that is 0.1 liter. So let's keep this as it is. 5 by 60 moles per liter is the volume of the solution in liter, right? Therefore pi will be is equal to what? Therefore pi will be is equal to 5 by 60 into volume of solution. C we got this. R is given as 0.083. Okay, one more is there, no? I'll write this to be I made a mistake. 0.1, and here also I'll write 0.1. This will come down, no? Numerator. And 0.083 into temperature is 27 degree, which is equal to 300 Kelvin, right? So this is, if you multiply this will be 5 by 6, 0.083 into 300, 3 2s and 50 into 5, 250. 5 into, so 25 into 0.083. If you multiply this 0.083, 20.75 units will be bar. 0.083, so units will be bar. This is the osmotic pressure.
A subject like physics can be a tough nut to crack in the last 40 days. But you need not worry if the subject experts are there with you. We are here at Prabhu Classes to guide you with a rank booster course for NEET 2024. So if you want to get a solid edge in your preparation, come and join us. Contact on the numbers given.
Yeah, this graph you can refer to NCRT and obviously get it. We'll calculate a mole fraction of the Ki. 20% they are saying, 20% of the Ki by mass. 20% Ki by mass means by mass. means 20 gram solute is present in 100 gram solution, right? 100 gram. So what is solute weight? Solution is equal to what? Solution is equal to solute plus solvent, right? Solution is 100 gram. Solute is how much? 20 gram. And what will be solvent? X. Therefore solvent weight, I will write not X, we'll just write this solvent only. So therefore solvent will be what? Solvent will be 80 grams. 100 minus 20. Now we have the weight of the solute and the solvent. You are told to find the mole fraction of Ki, right? So how do we write a mole fraction of the Ki? Mole fraction of Ki will be number of moles of Ki upon number of moles of Ki. Solvent is water, that is, so upon total number of the moles, right? Number of moles of Ki will be 20 divided by molar mass 127 upon 166. 127 plus 39, it comes to 166, right? And this is 0.120, and number of moles of H2O will be 80 divided by, number of moles will be how much? 80 gram, no? 80 gram divided by 18. This comes to 4 point something, 4.44. So therefore mole fraction of the Ki will be 0.120 divided by 0.120 plus 4.44, which is equal to 0.120 upon 4.56, which is equal to 0.026. So answer comes to 0.026. This is the mole fraction of the Ki over here. Okay, on the basis of the given data, answer the following questions. Of the galvanic cell is set up at 25 degrees Celsius with the following half cell. So actually over here the concentrations are given of the ions, right, of the electrolyte, and the reduction potentials are given. The one thing we have to understand over here is that one which is having the higher reduction potential, will undergo reduction. So if you compare between silver and the copper, silver is having higher reduction potential, right? It is having a reduction potential of 0.80 volt, and the reduction potential of the copper 2 plus going to copper is 0.34 volt, right? So which one is having the higher reduction potential? This is having the higher reduction potential, therefore it will undergo reduction, and this will undergo oxidation, right? See, we have to always remember this one word, LOAN, right? LOAN, left, oxidation, anode and negative. So oxidation, whichever is oxidizing will be anode, and it will be represented in a left side, right? So what they have said is, okay, representation is fine. Write the net cell reaction. First we'll write a half cell reaction, and then we'll write a net cell reaction. Okay, what is getting oxidized? So I'll write a oxidation half reaction. Oxidation half reaction. What is getting oxidized? Copper is getting oxidized. Copper will get oxidized to copper 2 plus by loss of 2 electron. And reduction half reaction is silver plus accepts 1 electron, and it changes to silver solid over here. This is very important, right? And now I combine overall reaction. Before you write a overall reaction, we need to make the number of electron getting transfer equal, right? Over here there are 2 electrons, and here there is just 1 electron, so I'll multiply this by 2 and I'll rewrite this. So 2 Ag plus 2 electrons and a 2 Ag solid. So these are the two reactions which I am going to combine, and your overall reaction, since overall reaction is asked, you can write this. This is the overall reaction for the thing. Overall reaction. That is copper, solid, 2Ag plus, these electrons will get cancelled, right? And a copper 2 plus and a Ag solid. Like this is the overall reaction which is expected. Is it possible to store a copper sulfate in a silver vessel, right? Like copper's reduction potential is given as how much? How much is the given value of the copper's reduction potential? .34 and other is 0.8. This is 0.34 and silver is given as 0.8. So since copper sulfate solution, like this is a silver vessel and you are storing a copper sulfate solution, let's say, yeah, copper sulfate, copper 2 plus, right? And sulfate ions will be there. What will happen to a copper ions? Is it possible to store a solution of copper sulfate in a silver vessel? What will happen in this case? Silver is having higher reduction potential, right? And copper is having lower reduction potential. So here silver is going to get reduced and copper ions. So we can store over here, we can store, because copper is already in a copper 2 plus oxidation state, right? So it cannot get oxidized further, right? It cannot get oxidized further. Therefore, this will not get reduced also, right? Therefore, we can store. Yes, answer is yes, we can store this. Calculate the EMF of a cell. See, Nernst equation. This is based on totally Nernst equation. E cell is equal to E naught cell. We write this, right? Minus, many students know this formula, 0.059 upon N log of concentration in a anode half cell upon cathode half cell, totally based on an overall equation, right? Over here, this 0.059 which we are having, okay, if you start with the reaction, if you start with the actual thing, it is this, how we are getting that actually. It is 2.303 RT by NF log of anode concentration in the cathode half cell. So this part they are telling us to take how much? 0.06. So instead of 0.059 I am taking that value to be how much? E naught cell minus 0.06 divided by N log of, like for this we require a anode half reaction and a cathode half reaction, the overall reaction we require, right? So what was that overall equation? What was that overall reaction which we got over here? So just copy this, copy to this. Yeah, this is that equation, so it is not so clean. What it is, clean this. Went to take shortcut, but Okay, I'll write that reaction again over here. Overall reaction. So in that overall reaction, I was getting 2 Ag plus and copper solid, copper 2 plus and 2 Ag. Right, this was the thing which was happening there. This is the reaction. Now we want in N over here. If you see in this case, what was the N? N is the number of electron getting transferred. So this was the N value which was getting cancelled, right? So N for this reaction is 2. N for this reaction is equal to 2, right? And E naught cell will be what? E naught cell is E naught cathode minus E naught anode. So cathode, which was having higher reduction potential, is 0.8 minus 0.34, right? Yes. So how much this going to come? Right, 0.46. Like 0.46 volt, right? So therefore, EMF of cell using Nernst equation is 0.46 minus 0.06 divided by 2 log of concentration of the product, that is copper 2 plus, into concentration of the silver. That's why overall reaction is important, which tells about the stoichiometric coefficients. Over here, concentration of the Ag plus the whole square and a concentration of the copper solid. Here also it is solid, right? So EMF of cell is 0.46 minus, to cancel this is 0.03 into log of, what is the concentration of the copper? Going back to the data, I don't remember. Copper is 10 raised to minus 1 and silver is minus 3. Copper is 10 raised to minus 1 and silver is 10 raised to minus 3. This will become 10 raised to minus 1 the whole square. Solid is 1 square. Here this is 10 raised to minus 3 the whole square. No, here square is not there. No, here square is not there. This is not there. This is not there. The square is not there. It's 10 raised to minus 3 and into this is 1. Right? Copper. This is 0.46 minus 0.03 into log of 10 raised to minus 1 and this is 10 raised to minus 6. So this is 0.46 minus 0.03 into log of 10 raised to minus 5, no, plus 5. .46 minus 0.03, 5 into log 10, log 10 is 1, log 10 is 1, so 0.46 minus 0.03 into 5 into 1, 0.46, so this will be what, 0.03. 0.15, right? 0.15, 0.31 volt. EMF of the cell will be 0.31 volt. Yes. Next question. Okay, again half cell reactions are given. Again here also half cell reactions are given. Not exact, this is not a half cell reaction, sorry. The reduction reaction. This is also a reduction reaction. And this is also a reduction reaction. So these are their E naught values. Means I can say that aluminum 3 plus getting reduced to this, its E naught value for this is minus 1.66. And for this, it is again reduction nickel 2 plus getting reduced to nickel. Again this is E naught is equal to minus 0.25 volt. Now on the basis of this data, represent a electrochemical cell using a nickel aluminum electrode as per the cell convention. If you see the values of the electrode potential, this is having higher reduction potential. So over here nickel is getting reduced, reduction is taking place, right? And this is having lower, so this is oxidation is taking place, means silver is getting oxidized. So while representing the cell, you will write silver, then this is Ag 3 plus, yes, oxidation. Ag is going to 3 plus 3 electron, sorry, aluminum, no, yeah, aluminum, not silver, I made a mistake. This is aluminum, that's what I am thinking, when aluminum started to going in plus 3 oxidation state. So this is aluminum solid going to aluminum 3 plus, then you represent a salt bridge, this is aqueous, and nickel which is in plus 2 oxidation state, which is aqueous, will go to nickel solid. This is a cell representation which is expected from you to write based on this data. Next is based on the same, among nickel and aluminum, which is better reducing agent. If you see the reduction potential of the thing, like nickels, question number 2 I am doing, nickel 2 plus getting reduced to nickel is minus 0.25, and aluminum getting reduced to Al, here E naught value is minus 1.66, is minus 1.66. Which is better reducing agent? See, reducing agent is the one which itself which reduces other and itself get oxidized. Now who is getting oxidized over here? This is the one who is getting oxidized. So therefore aluminum is better reducing agent, right? Nickel 2 plus higher reduction potential, the reduction itself get reduced, it oxidizes other, and this gets oxidized, reduction takes place over here and aluminum gets oxidized, right? Correct? Calculate the equilibrium constant. Next is calculate the equilibrium constant, they have asked. Calculate the equilibrium constant. At equilibrium, what is that equation? E cell, E naught cell, nonce equation I am writing 0.059, means I am writing this value 2.303 RT NF log of concentration in anode half cell upon cathode half cell product upon reactant. At equilibrium, E cell is equal to 0, E naught cell if you know this formula, I'm just deriving a formula, not required for you to derive. Even if you have not derived directly used formula, then also you will be correct. And this will be called as log of Kc at equilibrium, right? E naught cell, how much I was getting? So therefore E naught cell is equal to 2.303. This term we are taking how much? 0.06. N is 2 and log of Kc, right? Log of Kc, this is the formula, no? That is E naught cell into Nv, right? N is 2 over here, divided by 0.06. What was E naught cell over there? Log of Kc. E naught cell was much? No, E naught cell for this will be, which is cathode, minus 0.25 minus 1.66 minus 0.25 plus 1.66. So 1.66 minus 0.2514, 1.41. So this is 1.41 multiplied by 2 divided by 0.06.
A subject like physics can be a tough nut to crack in the last 40 days. But you need not worry if the subject experts are there with you. We are here at Prabhu Classes to guide you with a rank booster course for NEET 2024. So if you want to get a solid edge in your preparation, come and join us. Contact on the number given.
Equilibrium constant is asked. So this is log of Kc. Multiply this 2.88 and this is 0.06. Log of Kc is, can I write this 288 by 6? 288 by 6. So 6 4 and this is 8, right? 48. Yeah. So Kc, log of Kc I am getting equal to 48. So what will be a Kc equilibrium constant? Take antilog on both sides. Antilog of log of Kc is equal to antilog of 48. So antilog log, this is Kc, this is 10 raised to 48. This is the answer. Okay, select the carboxylic acid from the following which has the highest acidic strength. Okay, first we'll draw the structures. Structure 1 is 4-nitrobenzoic acid, and there is nitro group, benzoic acid, just benzoic acid, and this is 4-methoxybenzoic acid. Now what is the meaning of acid? What is the meaning of acid? When we say acid, what happens is that H plus is splitted up, right? Means in this case this will change to CO minus plus H plus, right? And this is NO2. In this case it will be changing to COO minus plus H plus. In this case this is changing to COO minus plus H plus, and here there is CH3. See, in which case the hydrogen will leave very easily where the stability of this negative charge is maximum. When the stability of this negative charge is maximum, then the hydrogen will do very easily. So this is the group which withdraws the electron density through minus m effect, right? Minus I is also there, but minus m is dominant effect. Here there is no effect. Here this shows the plus I effect. This is the group which destabilizes this negative charge, right? So best will be what? This NO2 is stabilizing this negative charge. So decreasing or increasing is asked. Okay, highest is asked. So highest will be 4-nitrobenzoic acid. Highest will be 4-nitrobenzoic acid. After that, it is benzoic acid. And the least will be 4-methylbenzoic acid. Okay, methoxy. Sorry. Yeah. Nothing going to, like, there won't be much difference. Methoxy, I just took this. This is methoxy. This is going to show a plus M effect. This is methoxy. Anyway, it is destabilizing through a plus M effect only. Whether it is methyl or methoxy, it is least acidic, that is 4-methoxy benzoic acid. Fine. So this is the order.
A subject like physics can be a tough nut to crack in the last 40 days. But you need not worry if the subject experts are there with you. We are here at Prabhu Classes to guide you with a rank booster course for NEET 2024. So if you want to get a solid edge in your preparation, come and join us. Contact on the numbers below.
Write the chemical equation for the preparation of the oxime. So this is the reaction. So when you get oxime, only when you use a hydroxylamine with a carbonyl compound. Okay, this is oxime is a general name for that, not an exact name. So this is the reaction which was expected to be written, and you should mention the name of this. This is ethanol. Okay, this is hydroxylamine. This is what? Etard reaction. This is the some name reactions they had told you to do with a methyl benzene, starting with a methyl benzene. That's it. And finally you get the aldehyde over here. This is the reaction. Then Clemenson's reduction is this. These reagents are important because many students get confused with the Clemenson's and Wolff-Kishner reaction because end products are same. Only thing, this reagent changes. So okay, select the compound that is most reactive towards nucleophilic addition reaction. So acetone, first I will write acetone. This is the structure of the acetone. Then acetaldehyde. Acetaldehyde is CH3 COH and propanaldehyde means CH3 CH2 C double bond OH, which is most reactive towards a nucleophilic addition. Nucleophile means basically where the nucleophilic addition takes place over here, because these carbons are partially positive. See, if you look over here, then the maximum, like OH minus, let's say nucleophile is something OH minus or anything, and negative, it will attack over here, right? Nucleophile will always attack on this carbon, like it will attack on that carbon easily where the magnitude of the negative charge is more, in which case the magnitude of the positive charge is more. The nucleophile will attack on that carbon where the magnitude of the positive charge is more. So in which case the magnitude of the positive charge is more over here. See, over here there are two electron donating groups. So here the positive charge which is formed due to electronegativity is somewhere neutralized to more extent. Here there is one electron donating group. Here also there is one electron donating group. But if you see, this is bigger R group, so it will neutralize this to more extent compared to this. So magnitude of the positive charge is more over here. So the answer is acetaldehyde. Okay, which will show most reactive, which will be most reactive towards a nucleophilic addition reaction. The answer is this. Write a chemical equation involved in a sodium acetate. When sodium acetate is heated with soda lime. Sodium acetate is what? CH3CO minus Na plus. What is soda lime? NaOH plus calcium oxide. This gives you this is actually a decarboxylation reaction. You will be removing the carbon dioxide from here, right? So finally what you get is CH3H plus Na2CO3. So you are getting the methane. This is methane. If you are writing this, then you are getting marks for this. Then last slide, preparation of acetophenone by a Friedel-Crafts acylation reaction. So acetophenone, how we are going to prepare is this. Acetophenone, this is benzene. To start with benzene, you take CH3COCl and anhydrous aluminum chloride. Actually in this case, this part, acyl part, acts as an electrophile. If you go into the depth of the mechanism, this forms the electrophile, and it is actually falls under the category of the electrophilic substitution reaction. So this is the reaction which was expected from you to write acetophenone. This is acetophenone. Reaction 2, this is ethanoyl chloride. And the last reaction, preparation of alpha bromo propanic acid by Hell-Wohlard-Zielinski reaction. So the reaction over here is Hell-Wohlard-Zielinski reaction, alpha bromo, like it is for the propanic acid. No, it's to start with this CH3 CH2COOH. This is propanic acid. You want alpha propanic acid. Reagents are, you want bromine, alpha bromo you want. So bromine and red phosphorus and water. Like this is alpha carbon because this is the functional group which is present. So the compound which you are going to get over here is bromine COOH. So this is alpha bromo propanic acid. You can also name this as, this is 1, this is 2, this is 3. So 2-bromo propanic acid also, 2-bromo propanic acid. So this is the whole illustration of the paper. Just check your answers well. Thank you.